right? Yeah. So all of you can able to see the screen, right? Yes. Can you all able to see the screen? Is it visible? Okay, fine. Okay, students. So let's go ahead. A very good afternoon to one and all, first of all. So we are dealing with the redox reactions, right? So yesterday we have started this lesson, and let me recall the topics we have discussed in yesterday's session. Okay, and then we will move on to the new topics for today. So moving forward with the lesson. So first of all, we have studied the redox reaction definition, and it says that it is the reaction in which oxidation and reduction reactions occur simultaneously, right, at the same time. So, and we have discussed about the definitions of oxidation and reduction. We have studied many definitions, right? Like around 2 to 3 definitions for oxidation, and 2 to 3 definition for reduction. So let us look into it one by one in a very fast manner. Then we will go for the next. So coming to the definition for oxidation, it is addition of oxygen or electronegative element, and reduction is removal of oxygen or electronegative element. And it is oxidation is the removal of hydrogen or electropositive element, and reduction is the addition of hydrogen or electropositive element. And according to the electron transfer concept, oxidation is loss of electron and reduction is called as gain of electron, right? Then after this, we have entered into the topic called oxidation number, right? What is an oxidation number? It is the real or imaginary charge present on an atom in a compound, right? So the charge acquired by an atom in a compound is called as oxidation number. And also we have started discussing the rules for calculating the oxidation number, right? So there are many rules, and we have discussed about 2 rules. We have discussed 2 rules in that. So the first rule is, for all the elements in their free state or uncombined state, the oxidation number is 0, right? Examples are nitrogen, N2, O2, H2. And if you take atoms like magnesium, aluminium, carbon, nitrogen, if you take a single atom which is present in its uncombined state, then the oxidation state based by that particular atom is 0. Okay, this is rule number 1. And rule number 2 is, for ions composed of only one atom, oxidation number is equal to the charge on the ion. So if only one atom like sodium is present, okay, and its charge is +1. So this is the charge on the ion, which is equal to the oxidation number. Okay, so these are the 2 rules which we have discussed in yesterday's session. So today we are going into the rule number 3 for calculating the oxidation number. Okay, so rule number 3 is about the oxygen story. Rule number 3 is about the oxygen story. So we are going to discuss about the oxidation number of oxygen. Okay. So first of all, mostly oxygen will have the oxidation number of -2. So mostly the oxidation number for oxygen is -2. For example, in H2O, if you see, we have 2 bonds, 2 OH bonds in H2O, right? So what will happen? How does a charge gets developed? Due to the electronegativity difference between the 2 bonded atoms. That's what we have discussed in yesterday's class, right? So we have 2 bonds, and both are OH bonds. And if you compare hydrogen and oxygen, who is more electronegative? Can anyone tell me which atom is more electronegative if you compare hydrogen and oxygen? The most electronegative element is hydrogen or oxygen? Can anyone give me the reply in the chat box? Very good, Manya. It is oxygen. Yeah, exactly, Sanket. It is oxygen. So what this oxygen will do? Oxygen will try to pull the shared pair of electrons towards itself, right? So it will take minus one charge from the first bond, and since hydrogen is losing its electron, it will take plus one. And for the second bond also, it will gain the electron. So totally the charge acquired by one oxygen is minus 2, which is the oxidation number of the oxygen in this compound. Okay, and for the hydrogen, it is plus 1. All right. So this is the common case for oxygen. But there are some exceptions for this oxygen. Okay, the first exceptional case is peroxides. So some of the examples for peroxide given here is H2O2 and Na2O2. And in these peroxides, oxygen takes minus one charge. So you know how it is taking minus one? So let me take one example to make you understand this. So let me take H2O2. So this is the structure of H2O2. So here we have three bonds, two OH bond and one OO bond. Okay, so you first take the OH bond. So if you take the OH bond, oxygen will gain one electron and hydrogen will lose. And if you take OO bond, both of them are same. Both the atoms are oxygen. Okay, so electronegativity value will be same for both. So in that case, nobody will pull the electrons from the one atom to the other. Okay, so there will be no charge separation. It will be 0. It will be 0 with respect to O bond. All right. Then if you go for the last bond, oxygen will gain and hydrogen will lose. So the charge acquired by one oxygen in this molecule is minus 1. Got it? So that's why in case of peroxides, oxygen takes the charge of minus 1. Is it clear to all of you? Can you all able to understand? Shall I go for the second exceptional case? Students? Shall we go for the second exceptional case? Yes. Yes. Okay, Bindu. So, Nandini, Sanket, thank you so much for your response. So, now we will go for the second exceptional case. Second is superperoxide, or we can call this also superoxide. Okay. KO2 and RbO2 are given as an example, and for these two compounds, for superoxides or superperoxides, oxygen takes minus 1 by 2. How does it take minus 1 by 2? So let me take one compound. Let me take KO2. So how does this KO2 gets dissociated? It gets dissociated as K plus and O2 minus. Okay, K plus and O2 minus, and this is called as superoxide. Okay, this is called as O2 minus is called as superoxide. And here you see one potassium is shared by two oxygen. One potassium is shared by two oxygen. So if it is plus 1, both the oxygen takes minus 1. So for one oxygen, so this is the bond. This is the bond between them. So both the oxygen has minus 1 charge. So for one oxygen, the charge that is shared is 1 by 2, 1 by 2. Then only if you add both 1 by 2, you will get 1. Clear? So there are two oxygen. So 2x is equal to minus 1. So x is equal to minus half. X is equal to minus half. And this is how we are getting the charge for oxygen as minus 1 by 2 in superoxides. Clear? Any doubt? Shall we go for the next slide? So mostly it takes minus 1. In peroxide it is, mostly it takes minus 2. In peroxide it takes minus 1, and in superoxide it is minus 1 by 2. Okay. So coming to the next compound, next exceptional case. It is for oxyfluoro compounds. The third exceptional case for oxygen is for oxyfluoro compounds. What is meant by oxyfluoro compounds? Oxygen and fluorine containing compounds. Okay. So there are only two compounds in which we have oxygen bonded with fluorine, and one among that is O2F2. So O2F2 is the oxyfluoro compound. And here oxygen takes the positive oxidation number, and that number is 1. Okay, so in the previous case, if you see, oxygen takes negative oxidation state. But here in case of oxyfluoro compounds, it is taking positive oxidation number, and that is +1. Okay, so let me show you how it is taking +1. How it is taking +1. So if I take the structure, it is O2F2. Okay, this is a structure of O2F2. And like we have done in the previous case for H2O2, if you start doing the charge separation for all the bonds, for the first FO bond, if you see, fluorine will get the -1 charge because fluorine is the first most electronegative element in the periodic table. Okay. Second most electronegative element is oxygen. First most electronegative element is fluorine. Okay. So what this fluorine will do, it will try to pull the electrons towards itself, making the oxygen positive. Okay. And for the OO bond, it is same, 0, 0. And for the second OF bond also, fluorine will get -1 and oxygen will get +1. Okay. So each oxygen is carrying +1 charge in case of O2F2. Okay. And the second compound is OF2. And here if you see, oxygen takes +2 charge. Here oxygen takes +2 charge. So the structure of OF2 is like this. It is a bent kind of shape. And with respect to the first OF bond, fluorine will get -1 and oxygen will get +1. And for the second bond, -1 and +1 like this. So one oxygen is carrying 2 plus charge. So that's why the oxidation number for oxygen in OF2 is +2. Okay. So how can we conclude this? If oxygen is bonded with the more electronegative element like fluorine than this, it will take the positive oxidation number. And according to the compound, the positive number will vary. Okay? Able to understand? Any doubt? Do you have any doubt from the students? So what was the first exceptional case? Peroxide. So in peroxide, it is -1. In superoxide, it is -1/2. In O2F2 +1, OF2 +2. Mostly it will have -2. So this is very easy actually. Okay, if you read this, it will be very easy. So please keep all these points in your mind. Yes, because this is a very basic lesson. So without knowing how to find out the oxidation number for certain elements, we cannot proceed or we cannot understand the other chemistry lessons. Okay. So you should be very thorough enough to calculate the oxidation number for each element. Okay. So this rules for calculating the oxidation number topic is very important. Okay. So if you're getting any doubts in between, please feel free to ask me, or if you want me to repeat once again, okay, please just let me know that in the chat box, I will repeat it. Okay. So without understanding anything, please don't sit and watch. Okay. So shall we go for the next? Shall we go for the next? No doubt. Okay then. So let's go for the next. So the fourth rule is about hydrogen story. Hydrogen, oxidation number of hydrogen. Mostly hydrogen will take +1 oxidation state. Mostly hydrogen will take +1. In case of water itself, we have calculated, right? So oxygen took -2 and each hydrogen took +1. So the oxidation number of hydrogen is +1 in most of the case. Okay. But here also there are some exceptional cases for hydrogen. The first exceptional case is when hydrogen is bound to metals. When hydrogen is bound to metals. So in case of H2O, hydrogen is bonded with the non-metal. Oxygen is a non-metal, right? It is a gas. So it is a non-metal. So if it is bonded with a non-metal, it is carrying, hydrogen takes +1 charge. But when hydrogen is bound to a metal, then it will take -1 charge. Okay, you can able to see the examples, right? Lithium hydride, sodium hydride, calcium hydride. If I take lithium hydride, Li plus H minus. Here Na plus H minus. And in case of calcium, calcium is a second group element, right? So it will be dissociated like this. Calcium 2 plus and 2H minus. Okay, and 2H minus. So in all these cases, if you see, hydrogen takes the oxidation number of -1. Okay, so lithium, sodium, calcium, all these are metals. When hydrogen is bonded to a metal, its oxidation number is -1. When it is bonded with a non-metal, the oxidation number is +1. Clear? Shall we go for the next? Shall we go for the fifth rule? So oxygen story and hydrogen story, both the stories are very important. So I hope everything is clear so far. If you're getting any doubt in between, please stop me, okay? I will go for the fifth rule now. Coming to the fifth rule, yeah, it is about the halogens. Who are the halogens in the periodic table? Can anyone list the halogens with the symbols? Here I have one halogen on the screen, and the name of this halogen is fluorine. And its atomic number is 9. And the oxidation number for fluorine is always -1 because it is the first electronegative element. Okay. Highest electronegative value containing element. Yeah, yes, Bindu. It is 17th group elements. Can anyone list the name or can anyone give me the symbol of 17th group elements? The first element is, first member of this group is fluorine. Who's the second member? Who is the second member? Yeah, very good, Nandini. It is fluorine, chlorine, bromine, and iodine. Right. So we have astatine, and that is a radioactive element. So we will not study about fluorine, chlorine, bromine, and iodine. Fluorine always takes -1 charge. It always gains an electron from the atom to which it is bonded. It never loses its electron. Okay. But when you talk about the other halogens, chlorine, bromine, and iodine, they also do carry -1 charge. They also have -1 charge. But when these elements are bonded with the highest electronegative value containing element other than this, then in that case, they will take the positive number. Okay. So for example, when chlorine, bromine, and iodine, when they are combined with oxygen, they form oxo acids and oxo anions. Okay. Oxo acid means HClO4. HClO4. So why it is called as an oxo acid? Because it has H plus, right? H plus and ClO4 minus. So if some compound is having H plus, it is called as an acid. And chlorine is bonded with oxygen here. Now in this compound, the oxidation state of chlorine is +7. It is +7. You know how it is taking +7? So this is HClO4, right? So Cl is taken as X because we are going to find out the oxidation number of chlorine. And for each hydrogen, we have to give +1 charge. So +1 plus X. And for each oxygen, it is -2, right? So 4 into -2 is -8. And this has to be equal to 0. So X will be equal to +8 -1. So it is +7. So this is how we are getting the oxidation number of chlorine as +7. This is the oxo acid. When you go for oxo anion means If you remove this hydrogen, you will have ClO4 minus ion, right? And that is called as oxoanion. So here in this compound, the oxidation state of chlorine is again +7. Again +7 because ClO4 minus, right? So this is taken as X. So the charge for each oxygen is -2. So 4 into -2 is -8. And here we have one minus. It means that it has gained one electron. ClO4 minus is an anion, right? So anion means it has gained one electron. So we have to put +1. Since it has gained it, we should write +1 and that should be equal to 0. And x is equal to 8 minus 1, x is equal to +7. Clear? So in both the compounds, in case of oxoacids and oxoanions, the oxidation state of chlorine or the halogen is positive. Clear? It is not -1 in all the cases. So in these two cases, positive oxidation number is taken up by the chlorines, that is the halogen. So you know why oxygen is more electronegative compared to chlorine, bromine, iodine. First most electronegative element is fluorine. Second most is oxygen. Okay, third most is the nitrogen and chlorine. Okay, so if chlorine or bromine or iodine is bonded with the more electronegative element like oxygen than them, they will get the positive oxidation number obviously. Clear? Can you all able to understand? Shall we go for the next rule? But if you talk about fluorine, it always carries -1 charge. Okay, this is also a very important point. It always carries -1 charge. Is it all right? Shall we go for the next? Do any of you have any doubts here? Shall we go for the next rule? Students say yes or no. Am I audible?
Yes, ma'am.
Okay. Thank you, Vikas, for your response. So now we will go ahead with rule number 6. For a compound, algebraic sum of oxidation number of all the atoms is equal to 0. Okay. Sum of oxidation number of all the atoms should be equal to 0 for a compound. Okay. For example, let me take the HClO4 itself. So here if I take the sum, so I know that the oxidation number of chlorine is +7, right? For chlorine it is +7 and for hydrogen it is +1 and for oxygen it is 4 into -2, -8. So if I sum up all these things, what I will get? 0. Okay. So for any compound, if you take the sum of oxidation number of all the atoms should be equal to 0. All right. If you take the polyatomic ion, polyatomic means more than 2 atoms containing ions. It can be a cation or it can be an anion. So for those cases, the sum of oxidation number of atoms is equal to the charge on the ion. It is equal to the charge on the ion. So for example, let me take one polyatomic anion for you. Okay. It is CO3 2 minus. It is CO3 2 minus. So for this particular polyatomic ion, if you sum up the oxidation number of all the atoms, it will be, for carbon it is +4, right? Its valency is +4. So it is +4. And here we have 3 oxygen and each oxygen carries -2 charge. So -2 into 3 is -6. And this 2 minus is the charge of the ion. CO3 2 minus. Okay. So this 2 minus is the charge of the ion. So if I calculate the oxidation number of these species, I'm having +4 and -6, right? Which is nothing but -2. And that -2 is equal to the charge on the ion. I am having the charge also as -2. Clear? Clear? Able to understand? Guys, can you able to understand? Let me take one more example also. SO4 2 minus. So here sulfur oxidation number is +6. Okay. And for each oxygen it is -2. So 4 into -2 is -8. And if I calculate this, what I will get? I will get -2. So this is the oxidation, algebraic sum of the oxidation number of the atoms given in the compound. And now the charge is also -2. So oxidation number is also -2. I mean the algebraic sum of the oxidation number is also -2. The charge is also -2. Okay? Clear? Clear or not? Nandini,
Yes, ma'am.
students, can you all able to understand the 6th rule and 7th rule? Okay, very good, Pragati. So now let's go for some more informations also. Okay. All the metallic elements will have positive oxidation number. All metals will carry positive oxidation number. For example, yesterday itself we have studied about group 1 metals and group 2 metals, right? Sodium, lithium, sodium, potassium, rubidium, cesium. And when you talk about group 2, beryllium, magnesium, calcium. So most of the metals will take positive oxidation number. Okay. So if I talk about sodium will have +1. If I talk about magnesium metal, it will carry +2. Okay. If I talk about aluminium, it will carry +3. So all these are metals and they will carry positive oxidation number. Okay. And all non-metallic element will carry negative oxidation number. All non-metallic element will carry negative oxidation number. Non-metallic means, let me take oxygen. So oxygen, what was the charge we have studied for oxygen? Mostly it takes -2. And what about for fluorine? For fluorine it is -1. Okay. So mostly the non-metals will take negative oxidation number. Okay. So then next, if you talk about transition metal means D block elements. The elements which are present at the center of the periodic table. They are called as D block elements, right? And the other name for D block element is transition metal. So they take several positive oxidation number. For one element itself, we have multiple oxidation state. Okay. For example, if I talk about iron is a D block element. Iron can have +2, iron can have +3. Okay. If I talk about manganese can have +1, +2 till +7. Okay. So likewise, transition metals, the D block metals take several positive oxidation number. Okay. So now I will give you some list of some of the group elements and their oxidation number. So here you can see that I have taken group 1, group 2, and from group 13 till group 17 elements. Okay. So in group 1 and group 2, I have sodium, magnesium, and from 13 to 17 onwards, aluminum till chlorine is filled. Okay. Now, the compound that each element will form is also given here. If you take sodium, it can form sodium chloride, magnesium sulfate, aluminum fluoride. Okay. The same way, the compounds of all the elements are given. And the oxidation number of that particular element in this compound is also given here. And in case of NaCl, it is Na plus and Cl minus, right? So the oxidation number of sodium is +1 here. And here it is magnesium 2 plus and SO4 2 minus. Oxidation state of magnesium is 2 plus. In case of AlF3, it is 3 plus. And for each fluorine, it is -1. For aluminium, it is +3. And in case of silicon, it is +4. And for each chlorine, it is -1. Okay. And here, if we calculate for P4O10, we will get +5. SF6 +6. And in HClO7, oxidation number of chlorine is +7. Okay. So the highest oxidation number or the highest oxidation state of the group element is given. For the first group, highest oxidation number is +1. For second group, it is +2. For 13th group, it is +3. For 14th group, the highest oxidation number is +4. Okay. What I'm trying to say is, if I'm talking about, let me take 15th group, okay? If I'm talking about 15th group, the highest oxidation number that it can exhibit is +5. Okay, it cannot exhibit +6. The 15th group element cannot exist in +6 form or +7 form. So that is not possible. Got it? 16th means +6. 16th group element cannot exist in +7 state. So are you getting my point? So the highest oxidation number is equal to the valency of the compound. Got it? So oxidation number increases from left to right. Oxidation number increases from left to right. I mean, if you go along the period in your periodic table. Clear, students? Do you have any doubts here? Able to understand? All metals will have positive oxidation number and all non-metals mostly will have negative oxidation number. The transition metals will have several positive oxidation number, and the highest oxidation number for a particular group is equal to the valency of that group element. Okay. Clear? Clear? Very good. So now let's go for, this is all about the rules. Okay. So we have studied 7 rules and some information about the metals, non-metals. So the next thing that we are going to discuss is individual oxidation number. I can give special cases as a name. Okay. So we are going to see some special cases, which is called as individual oxidation number. Okay. So we do have some exceptional special cases. So the first compound in the special case is C3O2, carbon suboxide. So for this species, the average oxidation number of carbon is taken as X. Average oxidation number of carbon is taken as X. So since I have 3 carbon, I have to take this as 3X. And we know that the charge for each oxygen is -2. And we have 2 oxygen. So 2 into -2 is -4. So that is equal to 0. 3x minus 4 is equal to 0. So what is the value of x? What is the value of x? Can anyone give me the value of x here? 3x is equal to 4 and x is equal to 4 by 3. X is equal to 4 by 3. Okay. So average oxidation number of carbon in this compound is 4 by 3. So now let's see the structure of this compound. We have 3 carbon and 2 oxygen. We have 3 carbon and 2 oxygen. Okay, so the structure looks like this. It is a linear structure. So we have 3 carbons. Okay, we have 3 carbons. If I take the first double bond, that is the double bond between carbon and oxygen, oxygen is more electronegative. So it will gain the electron. And since we have 2 bonds, 2 electrons will be gained. Okay, where there is a gain of 2 electron. So it will be -2 and +2. The carbon will lose the 2 electrons. And with respect to the second bond, second double bond, that is between carbon and carbon, it is 0 because the bonded atoms are same. Both of them are carbon. So it is 0. Okay. And if you move on to the third bond, again the bonded atoms are same. So it is 0 and 0. And when you look into the last bond, oxygen is more electronegative. So -2 for oxygen and +2 for carbon. Okay. So for the first carbon, it is +2. It is +2 and 0, so +2. For the second carbon, it is 0 plus 0, so 0. And for the third carbon, it is 0 and +2, so +2. So the total charge gained by the carbon is +2 for the first carbon and +2 for the third carbon. So totally +4. So that +4 charge is shared by 3 carbons. +4 charge is shared by 3 carbons. +2 here and +2 here. So +4 is shared by 3 carbons. Okay, so that's why we are getting the average oxidation number of carbon as +4 by 3. Okay, so let's go for one more compound. Br3O8, tribromo octoxide. Tribromo octoxide. So here the average oxidation number of bromine is taken as X. Okay, so if you go in the same manner, that is for bromine, we are going to calculate, right? So we have 3 bromine. So 3x minus 8 into -2. 8 into -2 is -16. It will be equal to 0. 8 into -2 is 16. So it will be equal to 0. And 3x is equal to 16. X is equal to 16 by 3. So this is the average oxidation number. Now let's go for the structure. 3 bromine and 8 oxygens are bonded in this manner. Okay. Now take all the bonds. So first you take one of the BRO bond. So when you compare oxygen and bromine, oxygen is again an electronegative element. So it is going to pull the electrons towards itself. So -2 plus 2. And for the second bond also -2 plus 2. For the third also it is same. Okay. Now if you go for bromine-bromine bond, oxidation number will be 0 because the bonded atoms are same, right? So it will be 0 with respect to this. And when you go for the top oxygen, it will be -2 plus 2. And for bottom also, it is -2 plus 2. And for the second BR-BR bond, it is 0. And for the remaining 3 also, the case is same. Okay. So we have 3 bromine. We have 3 bromine. The charge acquired by bromine 1 or the first bromine is +6. Right? The charge acquired by the first bromine is +6. So we have 3, 2, right? 3 plus 2, so it is +6. And if you talk about the second bromine, the charge acquired by the second bromine is +4. Okay, so it is having +2 plus 2, right? So totally it is +4. And when you go for the third bromine, it is also having +6. It is also having +6. So for first one also it is +6. For second one it is +4. And for third one it is +6. So totally we are getting +16. And that +16 charge is shared by 3 bromine. So the average oxidation number is 16 by 3. Are you getting my point? Understood? So if they are asking you to find out the average oxidation number of bromine for this particular molecule, you have to calculate like this. Otherwise, what they will do, they will ask you to find out the oxidation number of the middle bromine. So in that case, you can draw the structure like this and separate the charges and take out the answer as +4. So for the middle bromine, it is +4, right? So the answer is +4. Okay. And for the terminal bromines means you can go for +6. Terminal means the bromine which are present at the end. So each terminal bromine is carrying +6 charge. So accordingly, you can go for. Clear? Any doubt here? Shall I go for the next molecule? Shall I go for the next molecule, students? All of you can able to understand the special cases that I am teaching now, right? Special cases means We are drawing the structure and taking out the oxidation state of each element. Okay. Just by looking into the formula, you cannot find out the oxidation number of one atom. Okay. If you want to find out the oxidation number of a single atom, you have to draw the structure and get the answer. So that's why these molecules are coming under the special case. Yes, Nandini. What is your doubt? Oh, Pragati is having a doubt like, can you teach us to draw all the... Okay. Okay. Pragati, let me tell you something. If you want to draw a structure of a molecule, first of all, you need to know the number of bonds that an atom can form. Okay. So that you can get from the valency of that atom. Are you getting my point? That you can get from the valency of an atom. Okay. So let me explain you. So let me take the very simple molecule CH4. Okay, CH4. So I have one carbon and 4 oxygens. What is the valency of carbon? 4. It means that carbon can form only 4 bonds. Carbon can form only 4 bonds. Okay. And when you talk about hydrogen, we know that the valency of hydrogen is 1. So hydrogen can form only 1 bond. Okay. Hydrogen can form only 1 bond. Are you getting my point? So the structure becomes like this. So if I talk about the first special case molecule C3O2, okay, C3O2, we have 3 carbons. And we know that each carbon can form 4 bonds. And each oxygen can form 2 bonds. Do you remember? Oxygen can form only 2 bonds. In case of H2O, you see, oxygen
Yes,
is forming
ma'am.
2 bonds, right? Yes or no? In case of H2O2 also we have studied. H, O, O, H. So each oxygen can form 2 bonds. Each oxygen can form 2 bonds, right? So oxygen can form 2 bonds because its valency is 2. Carbon can form 4 bonds because the valency of carbon is 4. So according to the valency, we are getting the structure. So in the structure, we have seen for the C3O2, you just check whether each carbon is having 4 bonds or not. So take this first carbon, carbon 1, carbon 2 and carbon 3. So you see the number of bonds formed by the carbon number 1 is 4 and by carbon number 2 is 4 and by carbon 3 is also 4. Okay. And as I have told you, each oxygen can form 2 bonds and the number of bonds around each oxygen is 2 and for this also it is 2. Are you getting? Can you able to understand now? So this is how you
Yes,
have
ma'am.
to get the structure. Okay. You will get to know how to draw the structure for a compound if you practice this daily. Okay. Don't worry. You will get to know. Do not worry about this, but have a consistent practice over the lesson. You can get the answers and the structures. All right. Did I clear your doubt, Pragati? Understood?
Yes, ma'am.
You may ask me, like, ma'am, how do I know the valency and all, and how do I know where can I get the valency for all the elements kind of thing? All the informations related to valency and valence electrons have been taught to you in periodic table lesson. Okay. So at the end of the lesson, I have taught you the periodic properties of periodic chemical properties I have taught you. So in that trend, I mean in the periodic trend of chemical property, I have explained about the valency and valence electrons and the oxidation state. Okay, so there you can get the number of valence electron for each element. Okay, clear?
Ma'am, also,
Any doubt?
in bef yes, ma'am.
Did I address your
In
question?
before, In before question, we have
Compute
Br3O3, ma'am. In that, O3 is 3 in number, ma'am.
Able to
Ma'am,
understand,
in
my dear?
Br3, ma'am, in previous
Nandini,
example, in
does the
Br3O3, we
same
have
doubt you also
O3
had?
only, ma'am.
Because you did not ask me your doubt. You just said you have a doubt, but you did not tell me what is your doubt.
Yes, ma'am. The
Is this
doubt
same
is
doubt you
in
also had?
previous example.
In Br3O3, okay, I will come to this. Pragati, is your doubt clear? Shall I go for Nandini's doubt? Yes. Okay, coming to Nandini's question, ma'am, in Br3O3, in its structure, how we will get O6? It is not O6, my dear, it is O8. Oh my God. Oh my God. Sorry, I have made a mistake. It is Br3, it is not O3, it is O8, okay? Dear students, sorry for this, it is O8. Sorry, my dear. I have changed it, but I forgot to save the file, I think. That's why it has gone wrong. Is it clear now? It is Br3O8. The formula is Br3O8. It is tribromo, 3-bromine, and octoxide, right? So octa means 8. 8 oxygen. The formula is typed wrong by me here. Sorry for it. Okay? Okay, fine. So this is all about the special case, and I have got one more special case also for you guys. And that is S4O6 2 minus. You can take this as a homework and find out the average oxidation number of sulfur in this compound and try to draw the structure as I have told you and find out the oxidation number of each sulfur in this compound. So what are the 3 questions I gave you? So this is the question. Okay. First thing is you need to find out the average oxidation number of sulfur. Okay. Average oxidation number of sulfur. Pragati, please don't reveal the answer now. In the next session, I will ask you. Okay. So the second question is you need to draw the structure correctly. Then only you will get the answer. The third thing is find the oxidation number of each sulfur. How many sulfur we are having? 4 sulfur we are having. No, you have to find out the oxidation number of each sulfur. Okay. So try to take this as a homework and finish it before coming for the next class. All right. So I hope today's session is very useful for all of you. Thank you so much for attending the today's class and try to attend the next class also. Today I can able to see a lot of students attending the class. I don't know where were you guys for the last few days. Okay. So please try to attend all the classes without fail so that you can have a follow-up properly. Now I have launched a poll for you guys. So you guys can give your answers over there and then you can get ready for your next class. Okay. Thank you so much, students. Thank you so much. Thank you. Take care. Bye-bye.